Hi, this is Julie Harland, and I'm your Math Gal. Please visit my website at yourmathgal.com, where you could search for any of my videos organized by topic. This is part 2 of an introduction to graphing linear inequalities in two variables, and we graph y is less than or equal to 2x minus 3 and x plus y is greater than 3 on this video. In part 1 of our introduction to graphing linear inequalities in two variables, we graphed y is less than 2x minus 3. You see it over here on this graph. We have a dotted line where the line y equals 2x minus 3 would be, and then the shading in yellow below the line, those are the solutions. So this is the graph. Now, if you don't have to use highlighters, you could use hatch marks. So usually people just do that. They just to show that that's the solution, you just do this. All right, so you're showing that this side of that line, those contain all the solutions to y is less than 2x minus 3. So now we're going to go on and do y is less than or equal to 2x minus 3. All right, so we want to do y is less than or equal to 2x minus 3. This is really saying two things. This means y is less than 2x minus 3, or y could actually equal 2x minus 3. So if we put those two together, we'll have our answer. So when we graphed y equals 2x minus 3, we would just get a line, and that would be part of the solution to this. And then we just graphed y is less than 2x minus 3. So the only difference is instead of a dotted line, we're going to have a solid line at y equals 2x minus 3, since that's now part of the solution. So if you have a less than or equal or greater than or equal, it includes the line. So use a solid line, since that's part of the solution. All right, so the only difference to this problem would be that we would have a solid line. So let's look at how we did it in the previous problem. This is y is less than 2x minus 3. The only difference is this line here would now be solid as opposed to a dotted line, because now it's now part of the solution. All right, so here's the problem. Y is less than or equal to 2x minus 3. Step 1 would just be to graph y equals 2x minus 3 with a solid line, which I've shown over here on the right. Second part would be, again, to try to find which side of the line gets shaded. So pick a point, not on line, to see if it's a solution. Now, any ordered pair not on the line can work. Okay, so I'm going to try 0, 0, like I did in the first video, into y is less than 2x minus 3. So now I'm trying to find out, we already know where the solid line is. I'm actually just going to do the other part. Remember, this is broken up. I've got two things to graph. Y is less than 2x minus 3 and y equals 2x minus 3. Both of those together represent the solution. So I'm going to put in 0 for y, put in 0 for x, and I'm going to make sure if this is a solution or not. 0 is less than negative 3. False. So here's 0, 0, right here in the middle, and this is not a solution. Not a solution. So we want to shade the other side. So we shade this side of the line. This really goes up higher, so if you want, you could do that. Make it a little bit more accurate. Oops. I'll just leave it like it is. Something like this. All right, now just as a double check, I would pick some point over here where it's going through and make sure it actually works. So I'm going to try something that I do have it shaded through. How about I choose 2, 0? 2, 0. So I'm going to put in 0 for y, put in 2 for x, and that says 0 is less than 4 minus 3 is 1. True. So I do have it shaded on the correct side. Now, if you only have the y value on the left side of the inequality symbol, so in other words, it's just a y, it doesn't say 2y, it doesn't say x plus y, then this less than or equal, the less than tells you usually it's going to be below the line. Notice it got shaded below the line. I want all the y values below the line. So some people do that as well, but it's always good to check that it's really going through at least one of the correct ordered pairs. All right, let's try another problem now. All right, brand new problem. X plus y is greater than 3. All right, this just says x plus y is greater than 3, so we do not want the part x plus y equals 3. So step 1 is to graph x plus y equals 3 with a dotted line, okay, since x plus y equals 3 is not part of the solution. Now, how you decide to graph that, that's up to you. You could use the x and y intercept method. You can solve for y and put it in slope-intercept form. You can make a table of ordered pairs. Lots of ways to graph x plus y equals 3. So get out your own graph paper and graph the line x plus y equals 3, but remember to use a dotted line because that's not part of the solution. All right, here's my dotted line. That's x plus y is equal 3. Okay, it's not part of the solution, so I used a dotted line. I happen to use the x and y intercept method. I plugged in 0 for x and found out y was 3, so I got this ordered pair, and then I put in 0 for y and got x is 3 and got this ordered pair. But you could do any method you want. So if you happen to solve for y, you could have written that as y equals negative x plus 3. Right? And then you'd have a slope of negative 1, y-intercept of 3, etc. So just keep in mind how you graph it, that's up to you. Okay, now, next part. We need to decide which side of the line to shade. So you could pick any ordered pair that's not on the line. If it doesn't go through 0, 0, I suggest you choose 0, 0 because that's an easy ordered pair to plug in for x and y. So let's check 0, 0 in, and remember we don't put the less than part, we take the original inequality. All right, so let's put in, I'm sorry, greater than 3. So I'm going to put in 0 for x and 0 for y. And that says that 0 is greater than 3. True or false? False. So 0, 0 is not a solution. So I do not want to shade that part that goes through 0, 0. So I've got to shade the other side. So I shade this side, and there we have our solution. Now, let's say I had taken this original inequality and solved for y. By subtracting x from both sides, I'd have y is greater than negative x plus 3. And remember what I said, if you have just the y on the left-hand side, right, not negative y, not x plus y, etc., and this is greater than, then that means all the y values should be higher. So notice if I look at this dotted line, I happen to be shading above. I'm shading all the y values above those y values of the line. So that's a second way that some people do it. I always like to check an ordered pair to make sure Now let's make sure that one of the ordered pairs that it goes through, right, where you have shaded, really is a solution. Pick anything you want. How about 0, 5 right here, right? It's going through that point. So let's just check 0, 5. Check 0, 5. So I'm putting in 5 for y, right? And 0 for x, so negative 0 plus 3, and making sure that's true. Is 5 greater than 3? Yes. So I've got it shaded on the correct side of that dotted line. And so there we have our solution. We have our graph of x plus y is greater than 3. Please visit my website at yourmathgal.com where you can view all of my videos which are organized by topic.